The claim that the Earth is flat is not a modern invention. It is not something that was discovered by a brave group of independent thinkers in the Internet age. Flat Earth ideas have appeared and reappeared across various cultures at various points in history, but they have never survived contact with careful observation. Every civilization that looked at the sky seriously and reasoned carefully about what they saw arrived at the same conclusion, that the Earth is a sphere. The ancient Greeks understood this by at least 500 BCE. Eratosthenes measured the Earth's circumference to within a few percent in 240 BCE. Islamic scholars confirmed and refined that measurement in the 9th century. By the time European navigators were crossing the Atlantic, no educated person seriously doubted the spherical Earth. What makes the modern flat Earth revival worth addressing in detail is not that it poses any genuine scientific challenge. It does not. It is that refuting it properly requires surveying an extraordinary range of science. A flat Earth is not merely inconsistent with one or two observations. It is incompatible with the entire structure of modern physics. Gravity, orbital mechanics, atmospheric science, precision geodesy, relativistic timing, rotational dynamics, optical physics. Every one of these disciplines independently establishes the spherical shape of the Earth. And they do so using completely different principles, different instruments, different methods, and different mathematical frameworks. That convergence, 8 entirely independent categories of evidence, all pointing to the same answer, is the most powerful possible form of scientific confirmation. When methods that have nothing to do with each other all arrive at the same conclusion, the probability that they're all wrong in the same direction is not merely small. For practical purposes, it is 0. In this presentation, we're going to walk through each of those categories in detail. We will start with the oldest observations, the kind that any careful person could make by simply watching the sky, without any instruments at all. We will move through the classical measurements made by Greek and Arab scholars 2,000 years ago. We will examine the physics of gravity and rotation. We will look at the modern satellite evidence that pins down Earth's shape to millimeter precision. And we will consider, at the end, what would actually require for all of this evidence to be wrong, and why that alternative is not a coherent scientific position. The goal here is not to dismiss curiosity or to mock anyone who has questions. Asking questions about the world is the beginning of science, and it is a good impulse. But following those questions honestly all the way to where the evidence leads is what science actually requires. And every question about the Earth's shape, followed honestly to its conclusion, leads to the same place it has always led, to a sphere slightly flattened at the poles, 40,075 kilometers in circumference, confirmed by more independent lines of evidence than almost any other fact in human knowledge. Let us begin at the beginning, with the oldest proof available to human eyes, with a shadow on the moon. What a lunar eclipse shows us. On certain nights, when the Earth passes directly between the sun and the moon, something extraordinary happens. The full moon begins to darken. A curved shadow starts to creep across its face, slowly at first, then faster as it swallows more of the lunar surface. Within an hour, the moon may be entirely within Earth's shadow, a deep rust-red color from sunlight bent around the edges of Earth's atmosphere. Then the shadow withdraws, and the moon returns. This is a lunar eclipse, and it has been observed, documented, and thought about by human beings for at least 4,000 years. Babylonian astronomers were keeping systematic records of lunar eclipses by 747 BCE. Chinese astronomers recorded them even earlier. Greek, Mayan, Arab, and Indian astronomers all studied them carefully and left detailed accounts. Across all of these traditions, across all of these centuries, one observation was always, without exception, true. The edge of Earth's shadow on the moon is always a circular arc. Not sometimes circular, not approximately circular, always precisely a circular arc. Every eclipse, in every culture's records, in every century of recorded observation, regardless of where the moon is in the sky when the eclipse occurs, regardless of the time of year, regardless of the geometry of the sun, earth, and moon at that moment, the shadow's edge is always curved in the same way, always the arc of circle. The geometry of shadows, why this matters so much. To understand why this observation is so powerful, you need to think carefully about shadows. A shadow is simply the region behind an object where light cannot reach. The shape of a shadow depends directly on the shape of the object casting it. And the key insight is this. Different shapes produce shadows that change in different ways as the angle of the light changes. Take a flat disk, a coin, a plate, any flat circular object. When you hold it directly face on to a light source, it casts a circular shadow. But the moment you tilt it even slightly, the shadow changes shape. It becomes an ellipse, stretched and oval. Tilt it further, and the ellipse becomes more and more elongated, eventually becoming a long, thin sliver. The shape of the shadow produced by a flat disk is extremely sensitive to angle. It changes continuously and dramatically as the orientation of the disk changes relative to the light. Now, take a sphere, a ball of any kind. Hold it in front of a light source and rotate it in any direction. Turn it upside down. Tilt it sideways. Rotate it continuously. No matter what you do, no matter what angle the light comes from, the shadow is always a circle. Always. The edge of the shadow is always a perfectly circular arc. This is not an approximation or a tendency. It is a geometric certainty. A sphere is the only shape for which the shadow is always circular regardless of orientation. This fact was understood clearly by Aristotle around 350 BCE in his work on the heavens. He wrote that the Earth must be spherical because during lunar eclipses, events he and his contemporaries could observe, the shadow that falls on the moon is always bounded by a circular arc. He recognized that this was only possible if the shadow-casting object was a sphere. His reasoning was not speculation. It was geometric proof derived from direct observation. What the historical record tells us. Think about what it means that this observation has been made from every continent, by every major astronomical tradition, for over 4,000 years. The ancient Babylonians did not communicate with the ancient Chinese. The Greek astronomers did not share their data with the Mayan sky watchers. The medieval Arab astronomers working in Baghdad and Cairo were building on Greek traditions, but the Polynesian navigators who used the stars to cross the Pacific were not. And yet all of them, independently, saw the same curved shadow on the moon. The Babylonian eclipse records, known as the Serah series, preserved on clay tablets, document the pattern of eclipses across 18-year cycles with remarkable precision. These tablets describe the appearance of eclipses, and the shadow they describe is always curved. The Chinese astronomical tradition, which kept records independently for over 2,000 years, describes the same curved shadow. Medieval Islamic astronomers, who brought extraordinary mathematical precision to their eclipse observations, confirmed it. In the modern era, we have photographs and video footage of every total lunar eclipse. These images show the curved edge of Earth's shadow with complete clarity. There are 228 total lunar eclipses between 1900 and 2100. Every single one has been or will be photographed. Every single one shows a circular shadow edge. Not one deviation, not one ellipse, not one sliver. Always a circular arc. Why a flat Earth cannot produce this? For a flat disk Earth to consistently cast a circular shadow on the moon, Every lunar eclipse would have to occur at the precise moment when the disk is perfectly face-on to the sun, when the light strikes exactly perpendicular to the disk surface. At any other angle, a disk would cast an elliptical shadow. But lunar eclipses occur in all seasons, when the Earth is at different points in its orbit, when a moon is at different positions in its own orbit, and when the geometry between sun, Earth, and moon takes many different configurations. The idea that a flat disk would happen to be perfectly face-on to the sun in every single one of these different geometric configurations is not just unlikely. It is mathematically impossible. The geometry simply does not work. Furthermore, if the Earth were a flat disk and we did somehow always see circular shadows, those shadows would be circular with a very specific and predictable diameter, the diameter of the disk itself. But the shadow we observe on the moon is the shadow of an object whose size can be calculated from the geometry of the eclipse. That calculated size, every time, matches a sphere of radius 6,371 kilometers, Earth's known mean radius. The shadow is not just circular. It is the right size for the right sphere. There are 228 total lunar eclipses between 1900 and 2100. Every single one shows a circular shadow edge. The shadow size in every eclipse matches a sphere of radius 6,371 kilometers. This observation has been consistent across every astronomical tradition for over 4,000 years. The lunar eclipse is the oldest proof of Earth's spherical shape that exists. It requires no instruments. It requires no mathematics beyond simple geometry. It requires only a clear night, a full moon, and the willingness to look carefully at what is actually there. The bottom first disappearance. Stand at the edge of a harbor on a clear, calm day and watch a large ship sail away from you toward the open ocean. Watch it carefully from the moment it clears the harbor mouth until it is far out to sea. If you have good eyes or a pair of binoculars, you will see something that has puzzled, intrigued, and ultimately informed sailors for thousands of years. The ship does not simply shrink into a uniformly tiny dot and then vanish when it gets too small to see. It disappears from the bottom up. The hull, the great body of the ship below the waterline, sinks below the horizon first. Not because it becomes small, but because the surface of the sea swallows it. Then the lower deck disappears. Then the upper deck. Then the base of the masts. And finally, when everything else is long gone, the very tip of the highest mast disappears last. This bottom-first disappearance is not subtle. On a large ship at moderate distance, it is perfectly clear to the naked eye. The ship is being consumed progressively from below, as if the ocean surface is curving downward away from the observer, and the ship is following that curve, slowly dropping below it. Because that is exactly what is happening. Why perspective cannot explain this? The flat Earth explanation for this observation is that it is simply an effect of perspective, that distant objects appear to drop toward the vanishing point of a flat surface, and the bottom of a ship reaches that vanishing point before the top does. This is the explanation that most flat Earth proponents offer when confronted with this observation, and it sounds superficially plausible. But it fails completely when examined carefully. If perspective were causing the disappearance, the entire ship would shrink proportionally as it receded. Every part of it, hull, lower deck, upper deck, masts, flag, would become equally smaller at the same rate. The ship would fade out as a complete, proportionally shrinking unit. The hull would not disappear while the masts remained clearly visible. But more importantly, and this is the decisive test, perspective cannot hide something behind a barrier. Perspective makes things look smaller with distance. It does not put a physical obstacle between you and the object. On a curved surface, the horizon is a physical barrier. The curve of the Earth is between you and the hull of the distant ship. The hull is genuinely behind the curve, physically blocked from your view. And this is testable. Take a powerful telescope or a high magnification camera and point it at a ship that has already disappeared below the horizon. What do you see? You see the top of the mast. You can bring it back into view because the mast is still above the curve. But the hull stays hidden. No amount of magnification reveals it because there's a physical wall of water, the curve of the Earth, between you and the hull. The telescope makes the visible part larger, but it cannot see around the curve of the planet. If the disappearance were caused by perspective, a powerful telescope would reveal the entire ship, just very small. The fact that it reveals only the top while the bottom remains hidden is not a perspective effect. It is a barrier effect. There's a curve. The Bedford level experiment. Science done right. In 1838, a man named Samuel Rowbottom performed an experiment on a perfectly straight 6-mile stretch of canal in England called the Bedford level. He waded into the water at one end of the canal and looked through a telescope held just above the water surface. He expected to see a boat several miles away dropping below the horizon if the Earth were curved. Instead, he appeared to see the boat and concluded the Earth was flat. He was wrong. He had not accounted for atmospheric refraction, the bending of light rays near the ground due to temperature differences in the air. Near a water surface, warm air above cool water bends light downward in a way that allows you to see further than simple geometry would predict. Rowbottom was seeing a refracted image of the boat bent around the curve of the Earth. He had made a real observation, but interpreted it incorrectly by ignoring a known physical effect. In 1870, Alfred Russel Wallace, the co-discoverer of the theory of evolution with Charles Darwin, repeated the experiment correctly. He used 3 markers, one at each end of the canal and one in the middle. He accounted for atmospheric refraction by measuring from an elevated position and using the middle marker as a reference. His result was clear and unambiguous. The middle marker was significantly higher than a straight line between the 2 end markers, exactly as spherical Earth geometry predicts. The Earth curves. The experiment, done correctly, confirmed it. This episode is instructive beyond its immediate result. It shows how science works. An initial observation was made incorrectly because of an unconsidered variable. The experiment was redesigned to control for that variable. The corrected experiment produced a clear, unambiguous result consistent with a spherical Earth. This is the scientific method functioning exactly as it should. Polaris and the direct measurement of Earth's curvature. There is another observation that has been used by navigators for thousands of years that directly and quantitatively measures the curvature of the Earth. It involves the North Star, Polaris. Polaris sits almost directly above Earth's North Pole, within less than 1 degree of the true North Celestial Pole. This means that as you travel north or south across Earth's surface, the altitude of Polaris above your horizon changes in a precise and predictable way. The further north you are, the higher Polaris appears in the sky. At the North Pole, Polaris is directly overhead, 90 degrees above the horizon. At the equator, it sits on the northern horizon, 0 degrees of altitude. In New York, at latitude 41 degrees north, Polaris is 41 degrees above the horizon. In London, at 51 degrees north, it is 51 degrees above the horizon. In Tromsø, Norway, at 70 degrees north, it is 70 degrees above the horizon. The relationship is exact. The altitude of Polaris in degrees equals the observer's latitude in degrees. This one-to-one relationship between latitude and Polaris altitude is a direct, quantitative measurement of Earth's spherical curvature. Every degree of latitude you travel north, approximately 111 kilometers, raises Polaris exactly 1 degree in the sky. This linear, continuous relationship is a geometric fingerprint of a spherical surface. On a flat disk, Polaris would be a fixed point above the North Pole, and its apparent altitude would change in a completely different, nonlinear way as you moved across the disk. The clean, linear, one-for-one relationship we actually observe is only produced by a sphere. This has been used by maritime navigators since antiquity. The ancient Phoenicians used it. Greek sailors used it. Arab navigators in the Indian Ocean used it. Polynesian wayfinders understood the principle. Viking sailors crossing the North Atlantic used it. The relationship between Polaris altitude and latitude has been known, exploited, and confirmed by practical navigation for at least 3,000 years. The stars of the other hemisphere. If you board a flight from London to Sydney and step outside when you arrive, the night sky looks completely different. Polaris is gone. It is below the northern horizon, invisible from that latitude. The constellations that dominate the northern winter sky, Orion, Taurus, Perseus, Cassiopeia, Ursa Major, are either very low on the horizon or have disappeared entirely. In their place, dominating the southern sky, are constellations that are invisible from northern Europe and most of North America. The Southern Cross, Crux, is the most famous of them. It is a compact cross of 4 bright stars that has been used for navigation across the South Pacific, the Indian Ocean, and the Southern Atlantic for thousands of years. Indigenous Australians have mapped the sky using it for tens of thousands of years. The Maori of New Zealand use it. The peoples of the Pacific Islands use it. It appears on the national flags of Australia, New Zealand, Papua New Guinea, Samoa, and Brazil because it is the defining star of the southern sky, the counterpart of Polaris in the north. From London, you cannot see the Southern Cross at all. From Sydney, you cannot see Polaris at all. Entirely different stars dominate the skies of the two hemispheres, with a precise and measurable transition as you cross the equator. On a flat disk, this would be impossible. All stars would be visible from everywhere on the disk, some higher, some lower depending on your position, but none completely invisible. The fact that the northern and southern sky are genuinely, completely different, with stars that simply cannot be seen from the other hemisphere, is a direct and inescapable consequence of spherical Earth. It is impossible on a flat one. What gravity actually does to matter. Gravity is the force that shapes the large-scale structure of the universe. At small scales, on the scale of rocks, buildings, mountains, other forces dominate. The structural strength of rock and metal is far greater than the gravitational attraction between small amounts of mass. You can hold a brick in your hand. A brick-shaped piece of iron does not collapse into a sphere under its own gravity, because the iron is rigid enough to resist. But as objects get larger and more massive, gravity grows stronger relative to the internal rigidity of the material. And gravity has a crucial property. It pulls every part of a body toward every other part. It is not a force with a preferred direction. It pulls inward from all sides simultaneously toward the common center of mass. When gravity overcomes the structural resistance of the material it is acting on, the material flows. And when material flows under equal inward pull from all directions, it flows into the shape that minimizes the gravitational potential energy. That shape is a sphere. This is why every large astronomical body in the observable universe is spherical. The sun is a sphere. Every planet in our solar system is a sphere. Every large moon, Titan, Ganymede, Callisto, Europa, Triton, is a sphere. When astronomers observe distant stars, they are spherical. When we detect exoplanets around other stars, they are spherical. The pattern is universal and without exception. because it is not a coincidence. It is the inevitable outcome of gravity acting on sufficient mass. Asteroids, comets, and small irregular moons can be lumpy and misshapen because they are not massive enough for their own gravity to overcome the rigidity of their material. But once a rocky body reaches roughly 400 to 600 kilometers in diameter, its gravity is strong enough to win. It reshapes itself into a sphere slowly over millions of years. Earth is over 12,700 kilometers in diameter. It has had 4.5 billion years for gravity to work. It has been spherical for virtually its entire existence. The Earth is not a perfect sphere, and why that matters. The Earth is not a perfect sphere. It is very slightly flattened at the poles and bulges very slightly at the equator. The difference is not large, about 42 kilometers between the equatorial diameter and the polar diameter, out of a total diameter of over 12,700 kilometers. But it is real, it is precisely measured, and it is itself a powerful piece of evidence. Isaac Newton predicted this flattening in 1687 in his Principia Mathematica from pure physics. His reasoning was this: the Earth rotates. Every point on Earth's surface is moving in a circle as the planet turns, and that circular motion creates a slight outward push, what we experience on a merry-go-round as the tendency to be flung outward. This push is strongest at the equator, where the surface is moving fastest, about 1,670 kilometers per hour, and zero at the poles, which are on the rotation axis and are not moving laterally at all. The outward push at the equator causes material to bulge outward slightly, producing a shape that is wider at the equator than at the poles. Newton calculated the exact amount of this bulge from the known rotation rate of the Earth and the known laws of gravity. His predicted value for the flattening was approximately 1 part in 230. When modern satellite measurements were made in the 20th and 21st centuries, using GPS satellites, laser ranging stations, and dedicated gravity mapping missions, the measured flattening of the Earth was found to be 1 part in 298. Newton's prediction was not exactly right because he did not know the exact distribution of mass inside the Earth. But the prediction was of the right order of magnitude, and when more accurate internal density models are used, the match improves dramatically. The modern theoretical prediction, using everything we now know about Earth's internal structure, matches the measured flattening to better than 0.1%. Think about what this means. Newton derived his prediction from first principles in 1687, 280 years before we had satellites to measure the Earth's shape directly. The prediction he made about the exact amount of equatorial bulge was confirmed by 21st century satellite instruments to extraordinary precision. A theory predicting the exact shape of the Earth, confirmed 3 centuries later by space technology. This is not coincidence. This is physics working. The billiard ball comparison. There's a beautiful way to put the Earth's shape into perspective. If you scale the Earth down to the size of a standard billiard ball, the kind used in pool, with a diameter of 57 millimeters, the difference between the equatorial and polar radii would be smaller than the manufacturing tolerance permitted for official billiard balls. The Earth, at billiard ball scale, would be smoother and more perfectly round than the billiard ball itself. The highest mountain on Earth, Everest, at 8,849 meters above sea level, would correspond, at that scale, to a surface bump of about 0.08 millimeters. The deepest ocean trench, the Mariana Trench at about 11,000 meters depth, would be a depression of about 0.1 millimeters. The entire surface relief of the Earth, all its mountains and trenches and plains, would be invisible to the naked eye at billiard ball scale. The Earth is an extraordinarily smooth sphere. What gravity direction tells us about the Earth's shape? There is one more thing that gravity tells us, and it is perhaps the most direct argument of all. On a spherical Earth, gravity points toward the center of the planet everywhere on the surface, which means it points straight down, perpendicular to the local surface everywhere. Whether you're in Tokyo, Cairo, Sao Paulo, or Oslo, a plumb bob, a weight on a string, hangs straight down toward Earth's core. Now consider a flat disk. If gravity on a flat disk pulled toward the disk's center of mass, it would not pull straight down for people near the edge of the disk. It would pull diagonally toward the middle. Someone standing 5,000 kilometers from the disk's center would feel gravity pulling them at a sharp angle toward the center, like standing on a very steep slope tilted toward the middle. Buildings near the edge would lean inward. Rivers would all flow toward the center of the disk. The oceans would drain toward the middle. The atmosphere would pile up at the center and be catastrophically thin at the edges. None of this happens. Every building ever constructed using a plumb bob stands vertical. Every ocean surface is level, perpendicular to local gravity. Every river flows downhill according to local topography, not towards some global center point. The entire history of precision construction and engineering, every long bridge, every long tunnel, every long railway, every canal, has been built using spherical Earth geometry applied through the consistent direction of local gravity, and it all works perfectly. The great 19th century geodetic surveys that mapped the shape of entire continents. The great trigonometrical survey of India, which produced the first accurate maps of the subcontinent. The Struve geodetic arc that stretched from the Black Sea to the Arctic Ocean across 10 countries. All use the direction of local gravity as a reference. Those surveys closed correctly. Their measurements were self-consistent across thousands of kilometers, only because the Earth is the shape the surveyors assumed it to be. On a flat Earth, the angles would not have closed. The surveys would have accumulated systematic errors that would have been obvious and catastrophic. They did not. Why the sun's apparent size does not change. Here is a specific, measurable prediction that flat Earth models get dramatically wrong. One that can be checked with a camera and a solar filter by anyone. In the flat Earth model, the sun is described as a local object relatively close to the disk, circling above it like a spotlight. In some versions, the sun is placed at an altitude of a few thousand kilometers. If this were true, the sun's distance from any given observer would change considerably throughout the day. In the morning, when the sun is at the eastern horizon, it has moved to a far point on the disk. At noon, when it is directly overhead, it is at its closest. In the evening, it has moved again to a far point in the west. A nearby object that moves closer and further away appears larger and smaller as it does so. If the flat Earth sun model were correct, the sun should appear dramatically larger at noon, when it is overhead and close, and dramatically smaller at sunrise and sunset, when it has moved far away across the disk. The difference should be enormous and completely unmissable. But this does not happen. The sun's apparent size in the sky barely changes throughout the day. Precision measurements with solar telescopes and calibrated cameras show that the sun's angular diameter at noon differs from its angular diameter at sunrise or sunset by a fraction of 1%. That tiny variation exists, but it is due to Earth's slightly elliptical orbit around the sun, which brings us slightly closer to the sun in January and slightly further in July. The variation across a year is about 3%. There is no measurable change due to the sun moving closer and further during the day. The slight apparent enlargement of the sun near the horizon, the famous large-looking moon and sun at moonrise and sunrise, is a well-understood optical illusion caused by our brain comparing the celestial object to four round objects. When measured photographically with calibrated instruments, the sun at the horizon is the same size as the sun at noon. The illusion is in our perception, not in the physics. The sun looks the same size all day because it is 150 million kilometers away. At that distance, moving from overhead to the horizon changes the distance to the sun by less than one Earth radius, about 6,400 kilometers, which is less than 1/10,000th of the total distance. This change is too small to produce any visible change in apparent size. The sun is so far away that its distance is essentially constant throughout the day. A flat Earth sun at a few thousand kilometers altitude would show size changes of 30 to 50% between noon and the horizon. Enormous, completely obvious, and completely absent from every observation ever made. The observation matches only a very distant sun illuminating a spherical Earth. Time zones, the geometry of rotation. The Earth rotates once every 24 hours. As it rotates, it presents different parts of its surface to the sun at different times. The side currently facing the sun is in daylight. The side facing away is in night. And as the Earth turns, that day-night boundary, called the terminator, sweeps across the surface at a rate of 15 degrees of longitude per hour. This is why time zones are 15 degrees wide. When it is noon in London, it is 2 in the afternoon in Cairo, 8 in the evening in Bangkok, and 3 in the morning the next day in Auckland. These time differences are not political conventions or arbitrary choices. They are direct, quantitative consequences of a spherical planet rotating at a precisely measured rate. On a flat disk with a local circling sun, time zones as we know them are geometrically impossible to produce. A local sun circling above a disk would illuminate a sweeping region of the disk as it moved, with a gradual transition from day to night around the edge of its illumination cone. It would not produce the clear, simultaneous day-night split that allows one side of the world to be in complete darkness while the other side is in full daylight. More telling, the predicted time differences between cities in the flat Earth model do not match reality. The spherical Earth model predicts that London and New York should differ by 5 hours, because New York is 75 degrees west of London, and 75 divided by 15 is 5. And indeed, New York is exactly 5 hours behind London. The model predicts the time difference between Sydney and Los Angeles should be 19 hours. And it is. Every time zone on Earth matches the prediction of a rotating sphere to within a few minutes, adjusted only for the practical necessity of having political borders define the exact zone boundaries. The variation of day length with latitude. At the equator, day and night are almost exactly equal year-round, about 12 hours of daylight and 12 hours of night every day. But as you move away from the equator, this changes. Days become longer in summer and shorter in winter. The closer you get to the poles, the more dramatic this variation becomes. At the Arctic Circle, 66.5 degrees north latitude, there's at least one day per year with 24 hours of continuous daylight, and at least one day with 24 hours of continuous night. These are not myths or exaggerations. They are facts experienced every year by the millions of people who live in northern Norway, Sweden, Finland, Iceland, Alaska, and northern Canada. The midnight sun is a documented, photographed, annually recurring phenomenon. At the North Pole itself, there are 6 months of continuous daylight, from the spring equinox to the autumn equinox, followed by 6 months of complete darkness. Every polar expedition in history has documented this. The mathematics of why this happens is straightforward spherical geometry. The Earth's axis is tilted 23.5 degrees relative to its orbit around the Sun. In summer, The pole is tilted toward the sun and stays in sunlight for the entire rotation. In winter, it is tilted away and stays in darkness. The precise formula for day length at any latitude on any day of the year produces results that match observation everywhere on Earth to within seconds. The formula is derived purely from spherical geometry applied to a tilted, rotating sphere. No flat Earth model has ever produced a formula that correctly predicts day length at all latitudes simultaneously. Not a close approximation. Not an adjusted version. Never. The spherical Earth formula works everywhere. The flat Earth alternative fails everywhere except a narrow region near the model center. The Antarctic midnight sun, a decisive falsification. The most devastating specific test of the flat Earth model is the southern hemisphere midnight sun, and it deserves extended attention. In the most common flat Earth model, the Arctic sits at the center of the disk. Antarctica is described as a surrounding ice wall at the outer rim. The sun is described as a local light source that circles above the disk, spending more time over the center during the northern summer, which is why the model claims the northern summer has long days. In December, the northern winter, the sun is circling at a smaller radius closer to the center, and the outer regions of the disk therefore receive less light. This prediction is catastrophically wrong. In December, the southern hemisphere is in summer. Australia has long summer days. South Africa is in midsummer. Southern South America, Argentina, Chile, Uruguay, is experiencing its hottest and longest days of the year, and Antarctica itself is in continuous daylight. The entire continent experiences 24 hours of sunlight per day for months at a time during the southern summer. In the flat Earth model, Antarctica is the outermost ring of the disk. In December, according to the flat Earth sun's circling pattern, the outer ring should be receiving the least light. It should be in near perpetual darkness, but it is actually in continuous daylight. The flat Earth model predicts permanent near darkness for Antarctica in December. The actual observation is the polar opposite. Antarctica has the longest days on Earth in December, and it has been documented continuously by every Antarctic research station and every polar expedition for over a century. The British Antarctic Survey, the Australian Antarctic Division, the U.S. Antarctic Program, the Argentine Antarctic Institute, the Russian Antarctic Expedition. Researchers from multiple nations operate year-round at Antarctic stations, and they all document the same thing: continuous daylight in the southern summer. This is not a government fabrication. It is the experience of thousands of scientists and support personnel every year. No adjustment to the flat Earth model can fix this problem. It is not a matter of fine-tuning the parameters. The geometry simply does not allow a disk model to produce summer simultaneously in the northern regions and in the outermost edge. On a sphere with a tilted axis, both hemispheres get their own summer at opposite times of year. This is exactly what we observe. The flat disk model has no explanation for it. Alexandria, 240 BCE. In the city of Alexandria in Egypt, around the year 240 before the Common Era, a remarkable man named Eratosthenes was serving as the chief librarian of the Great Library. The Library of Alexandria was, at that time, the greatest repository of human knowledge in the world, housing hundreds of thousands of scrolls covering mathematics, medicine, poetry, philosophy, history, geography, and astronomy. Eratosthenes was one of the most intellectually versatile scholars of the ancient world. He was a mathematician, a geographer, a poet, a philosopher, and an astronomer. His contemporaries nicknamed him Beta, second, because he was said to be the second best in the world at everything he turned his hand to. This was not an insult. It was an acknowledgement of extraordinary breadth. One day, Eratosthenes encountered a piece of information about a city called Syene, what is today the city of Aswan in southern Egypt, located on the Nile roughly 800 kilometers south of Alexandria. The information was this: at solar noon on the day of the summer solstice, the longest day of the year, a vertical stick in Syene cast no shadow at all. And if you look down into a deep, narrow well at that moment, you could see the reflection of the sun at the very bottom. The sun was directly overhead. Perfectly, exactly straight up. Eratosthenes was interested because he knew that in Alexandria, on that same day, at that same moment, solar noon on the summer solstice, a vertical stick did not behave this way. It cast a shadow. The sun was not directly overhead in Alexandria. It was tilted slightly to the south. The argument that changes everything. Eratosthenes measured the angle of the shadow in Alexandria at solar noon on the summer solstice. He found that the sun was about 7.2 degrees away from vertical. The shadow made an angle of 7.2 degrees with the stick. Now he reasoned as follows. The sun is far away, so far that its light arrives at Earth essentially as parallel rays. This was understood by Greek astronomers. If the Earth were flat, parallel rays from a distant sun would strike every vertical surface on the flat Earth at the same angle. A stick in Alexandria and a stick in Syene would both cast shadows at the same angle, or both cast no shadow at all if the sun were directly overhead. There would be no difference, but there was a 7.2 degree difference. And the only way parallel rays from a distant source can strike two locations at different angles is if the surface between those locations is curved. If the surface curves by 7.2 degrees between Alexandria and Syene, then those two cities are separated by 7.2 degrees of arc on the surface of a sphere. And a full circle is 360 degrees. So the ratio of the Alexandria-Syene arc to the full circumference is 7.2 divided by 360, which simplifies to 1 divided by 50. Alexandria to Syene is 1/50th of the full circumference of the Earth. Eratosthenes then needed to know the distance between Alexandria and Syene. He knew it was approximately 5,000 stadia, a unit of measurement used in the ancient Greek world. Multiply 5,000 stadia by 50, and you get 250,000 stadia as the circumference of the Earth. Converting to modern units depends on which exact type of stadium Eratosthenes was using. Using the Egyptian stadium of approximately 157.5 meters, his result translates to approximately 39,375 kilometers. Using the Attic stadium of 185 meters, it gives 46,250 kilometers. The modern measured circumference of the Earth at the equator is 40,075 kilometers. Depending on the conversion factor, Eratosthenes was within 1.5% to 15% of the correct answer, using nothing but a stick, its shadow, and geometry. Why the method matters more than the result. The precision of Eratosthenes' numerical result is remarkable, but the most important thing about his work is not the number. It is the method. The method requires the Earth to be spherical in order to work at all. On a flat Earth, two vertical sticks at any two locations receive parallel sunlight from a distant sun at exactly the same angle. If the sun is directly overhead in Syene, it is directly overhead everywhere. If it casts a 7.2 degree shadow in Alexandria, it casts a 7.2 degree shadow in Syene too. There is no difference to observe, and there is no way to use shadow angles to calculate a circumference. The entire method only makes sense, only produces a meaningful result, if the Earth's surface is curved. The method is not just consistent with a spherical Earth. It requires one. Furthermore, Eratosthenes' method has been replicated and confirmed independently by multiple civilizations using different techniques as we will see, and every independent measurement converges on the same value. This convergence is the hallmark of correct science. 3 independent confirmations across 19 centuries. In 827 CE, more than 1,000 years after Eratosthenes, and a world away geographically and culturally, the Abbasid Caliph Al-Ma'mun commissioned an independent measurement of the Earth's circumference. Al-Ma'mun was one of the great patrons of science and history. His court in Baghdad attracted mathematicians, astronomers, physicians, and philosophers from across the Islamic world and beyond. He wanted to know, from direct measurement, how large the Earth was. The scholars he commissioned chose a flat, featureless plain in what is now Iraq or Syria. Accounts differ on the exact location. 2 teams set out from a common point, one heading due north and one heading due south. Each team walked until the altitude of Polaris above the horizon had changed by exactly 1 degree, which on a spherical Earth corresponds to exactly 1 degree of latitude, or approximately 111 kilometers. They measured that distance as carefully as they could using standardized units of measurement. Then they multiplied by 360 to get the full circumference. Their result was approximately 40,248 kilometers. The correct value is 40,075 kilometers. They were within less than half of 1%. They had never seen Eratosthenes' original calculation. They used a completely different method, walking measured distances on the ground rather than comparing shadow angles. And they got essentially the same answer. In 1670, the French astronomer Jean Picard performed yet another independent measurement, using the technique of triangulation, a far more sophisticated method involving the precise measurement of angles across a chain of triangles spanning several hundred kilometers in France. He combined these angle measurements with direct distance measurements to calculate the length of 1 degree of latitude with high precision. His result corresponded to a full circumference of approximately 40,036 kilometers, within 0.1% of the modern value. Isaac Newton used Picard's measurement to verify his own gravitational theory about the moon's orbit. Without Picard's accurate Earth radius, Newton's calculation of the moon's orbital period would not have matched observations as well as it did. 3 independent measurements, 3 different centuries, 240 BCE, 827 CE, 1670 CE, 3 different civilizations, 3 different methods, all producing results within 0.5% of each other, clustered around 40,000 kilometers. This convergence is not a coincidence. It is what a correct measurement looks like when repeated correctly by different people using different approaches. The honest conclusion: the history of human knowledge about the shape of the Earth is one of the most impressive examples of the scientific method succeeding over very long timescales, beginning with simple naked eye observations available to anyone, moving through increasingly precise measurements using increasingly sophisticated instruments, and culminating in millimeter precision satellite geodesy. Every step of the process has confirmed and extended the same finding. The Earth is an oblate spheroid, a sphere slightly flattened at the poles. Its mean radius is 6,371 kilometers. Its equatorial circumference is 40,075 kilometers. Its equatorial radius is 21 kilometers larger than its polar radius. It rotates once every 24 hours and orbits the Sun once per year on a slightly elliptical orbit with the Sun at one focus. These are not beliefs or interpretations or governmental positions. They are measured physical facts confirmed by 8 independent branches of science, tested and retested by researchers from dozens of countries across thousands of years, accurate to the precision of the best instruments available at each stage of history, and continuously verified in real time by the GPS systems, weather forecasting models, airline navigation systems, and satellite communications that billions of people rely on every day. Aristotle inferred the shape from eclipse shadows in 350 BCE. Eratosthenes measured the circumference in 240 BCE. Al-Ma'mun's scholars confirmed the measurement in 827 CE. Newton predicted the equatorial bulge in 1687. Satellites confirmed it to millimeter precision in the 21st century. Every careful observation ever made, in every culture, in every era, has told the same story. The Earth is round. It has always been round. We have known it with continuously improving precision for over 2,500 years.